Alright guys, today I'm going to show you how to solve one-step equations that are with addition and subtraction. So just a couple things before we do that. I wanted to show you why in 7th grade we are learning this, because eventually when you get into 9th grade you're going to have these kind of advanced equations and how you're going to have to solve for your variable of x. So we need to show you a process that you can use consistently to kind of build up to that. And so we're going to show you a little bit in 7th grade, a little bit more in 8th grade, and that way with 9th grade you'll be able to practice these problems. So this is why it's really important for us to show our work and not just do these in our head. So for example, if you see addition in the problem itself, then you're going to solve the addition with the inverse operation. That means subtract. So you can think about what you do to one side of the equation, you must do to the other. So then if we see subtraction in the problem, we're going to solve it with addition. So the reason why we're going backwards is we're saying that some number plus 4 gave me negative 8. So we're going to solve that with subtracting that constant of that positive 4 to work backwards to get there. So this is just kind of like a seesaw, a balance beam, so that way we know that we can't just subtract the 4 on this side and not on that side. That would give us a different value. So what I also like to do is I draw a line to separate what I do to one side, I do to the other. So if I see plus 4. This is really hard for us to do in our head. Some number plus 4 is negative 8 because our brains don't naturally work in negatives. That's why we want you to show your process. So I get rid of the plus 4 by solving it with a negative 4. So I'm either subtracting 4 or adding 4 negatives to either side. That means the same thing. So these cancel out and gets me x by itself. If I have 8 negatives, I can't technically take away 4 positives. So that's why we taught you already with combining integers. We can think about a number line, or we could add a line, change an x sign. So 8 negatives combined with 4 negatives is negative 12. And here's the other good thing about these. You can always see if you're right before your teacher even grades it with substitution. If you take this number and put it back where you have x, 12 negatives combined with 4 positives, the signs are opposite, so you subtract. 12 minus 4 is 8, and there were more negatives, so your 8 is going to be a negative sign. Or if you went 12 to the left on a number line and 4 to the right, you're going to land at negative 8. So it's a really good practice for y'all to check every single time so that you know if your value is actually correct. If this were a test, positive 12 would be a trick answer. That's why we want you to check your work. You can check with substitution every time. All right, so some value minus 2 equals negative 5. Again, our brains don't naturally work in negatives, so that's why we want you to show your work, especially showing your work now, so when you get to these kinds of problems, you know what to do step by step. So I see subtract 2, so I get rid of subtracting with adding 2. You're trying to get that variable by itself. So we get rid of the negative 2 or the minus 2 with addition, with adding the 2. So x is now by itself over here, and negative 5 combined with 2. I can think about a number line. I can think about my integer chips. Anything, what strategy we've already taught you. So 5 negatives combined with 2. The signs are opposite, so you actually subtract. And who are there more of, or who has the bigger absolute value, is going to be the sign of your number. So we're predicting it's negative 3. Again, you could use substitution to check. Negative 3 minus 2 equals negative 5. Now we talked this out, but I'll show you with the work here. Well, subtraction, remember, see subtraction, add a line, change the next sign. And 3 negatives combined with 2 negatives is negative 5, so it checks out. You know you're right. That's what we want you guys to do, especially on these one-step equations, so that when we get to the more advanced two-step equations and those other ones, this is called distributive property and combining like terms, which you'll see that next year in 8th grade and 9th grade, that you're ready for those. So let's do a few more examples together. I'll do these examples on the left, and you can try those examples on the right if you'd like. All right, so 2 plus n. It doesn't matter which side the variable is on or if the variable is first. But on the side with the variable, what are we doing? We're adding this 2. Now this 2 is a positive because there's no sign in front of it. So if it doesn't have a sign in front of it, we know it's positive. So we get rid of a positive 2 with 2 negatives. So I see addition, so I'm going to solve it with subtraction or adding the negatives. Remember, adding negatives is the same thing as subtracting. Okay, so 6 minus 2 is 4. And a lot of you say, well, yeah, I know I can do that in my head. 2 plus 4 is 6, so you know you're right. But this is how you show it to get the credit. Okay, so I see another addition, but this is where it tricks you. This is a positive x, but you could actually rewrite this, if it helps you, x plus negative 6. So really and truly, yeah, you see the addition, but the integer that we're trying to get rid of is this negative 6. So if we want to get rid of a negative 6, we're going to add a 6. Okay? We're trying to get rid of this integer, and that's a negative 6, so we're going to get rid of that negative 6 with a positive 6. So negative 12 combined with 6 positives, we'd have some 0 pairs. Signs are opposite, so we subtract. We take the sign of who there are more of. And again, especially on this one, we can double check. Negative 6 combined with negative 6. We're substituting that value, what we got. A negative combined with negative. Yep, that would give me negative 12. When the signs are the same, we add and keep the sign the same. When the signs are opposite, we subtract and take the sign of who they're more of. Okay? So again, let's look at this one. Some value minus 9 is getting you to 12. So don't let that confuse you. It doesn't matter what side the variable's on. It just matters what operation do you see with the variable. So the opposite of subtract is addition. So we're going to add 9 to both sides. So I would think about this as 12 plus 10, which is 22, but we added an extra one, so take one away, it's 21. So 21 is equal to x. And sure enough, when you substitute that back in, 21 minus 9 is 12. So it just takes practice. So on the side of the variable, we see a 7 plus y. So again, we can rewrite that if we like, or we can just think of that as a positive 7. So the opposite of a positive 7 is a negative 7. So we add 7 negatives to both sides. That cancels out. Negative 9, taking away 7 positives the way this is written, we can't do. So remember, when we see subtraction, we add a line, change the next sign. So 9 negatives combined with 7 more negatives is negative 16. Okay, 2 more, and then you can try these 3 out on your own if you like. Just takes practice. All right, negative 4 and 5 plus x. Well, are we going to get rid of that negative 4, or are we going to get rid of that 5? Let me just kind of zoom this in. It's a little blurry. All right, so think about this integer as a positive 5, so we get rid of a positive with 5 negatives. Inverse operation. So that isolates the variable. That's what we want. Isolate means get by itself. We want to know the value of x. Negative 4, take away positive 5, we can't do because we add a line, change the next sign. So negative 4 combined with 5 negatives is negative 9. Okay? And then let's look at this last problem. N minus 3 is equal to negative 15. Well, this is subtracting 3, so we get rid of subtracting 3 with 3 negatives. Or excuse me, with 3 positives. Even if you were to rewrite this, add a line, change the next sign, that's 3 negatives that you're trying to get rid of. So however you think about that, that's what we're trying to get rid of that. So 15 negatives combined with 3 positives, we're going to have some 0 pairs. We'd have 3 0 pairs. The signs are opposite, so we subtract. 15 minus 3 is 12, and there are more negatives, so that is going to be my answer. It's negative 12. Again, you can recheck. Negative 12 minus 3 was my original problem. If you went 12 to the left on a number line and 3 more to the left on the number line, you would land at negative 15. Or we could add a line, change the next sign, and that still works out. 12 negatives combined with 3 more negatives does equal negative 15. So this is how you should be working out these problems step by step. So not only can we solve the one-step equations, then the two-step equations, and eventually we can get to these problems like this. Because we'll teach you step by step so that you guys will get here to understand how to do it.